looking at number 1. It says, practice word problems for Unit 3. A plumber charges $154 to fix a blocked drain for a total of 4 hours of work. The plumber charged the same rate for each hour. Which diagram represents the constant rate of change for the situation? Okay, important wording right here. Same rate for each hour. So really we want the per hour rate. He did 4 hours of work and charged $154 to fix it. Okay, so which diagram represents the constant rate of change? So we're looking for the constant rate of change, which is generally going to come out to a unit rate. Okay, so in this case it's going to be the cost per hour. So we're looking for the diagram that best fits this situation. Okay, so if you break this down, the wording says $154 per hour. So $154 for 4 hours. Our words would be cost per hour. How much for 1 hour? So if I solve that, I would figure out that 154 divided by 4 is, I got it. Okay, so it's going to be subtract here. We're going to drop down our 4. It's going to go in there 8 times. It's 32. And we're going to get 38.5. So really he's making about $38.50 per hour. Okay, so if you look at your numbers, okay, this one, A is saying that 38.50 4 hours, 38.50 4 hours. So that doesn't really make sense because that really doesn't break it down per hour, does it? Does that show a constant rate? Okay, so I don't agree with that one. Okay, B, 38.50 per hour, the total of 4 hours. Okay, that one looks right. Let's check out C. 1 hour, 2 hours. Well, that's saying that 2 hours would be 154 to me. And that's not true, right? 4 hours is 154. And it's not 154 per hour. So our answer is answer choice B. Okay? Okay, so moving on. Look at number 2. The table below shows the time it takes the glider plane to travel different distances. What is the constant rate of change in miles per hour? So we talked about this a lot, guys. This is minutes. These are all in minutes, and we want an hour. Okay, so we need to think about the conversion there. How many minutes are in an hour?
60.
Or 60? Just 60? 60? Or 60? How about 60? So how would we write? You are saying too many 60s, I think. Okay, so I would write it like this. So what would my words be? We would have, remember we did miles per hour. I would say miles per minute here. Right? That's really what we want, miles per minute. Because we can get a whole hour if we put in minutes. So I want you to find your known. We're looking for our unknown, how many miles in how many minutes. We're looking per hour, so we're looking for how many minutes? 60. So find me a known, put it in there, and let's try to solve this. Okay, I did it this way. So I went up here and I said, man, I wanted to get to 60. So which one would be the easiest? Well, this one would be okay because it's 15. 15 times 4 is 60. But this one looks way easier because it's 30 minutes. So if I put 30 minutes on the bottom, how do I get to 60? Well, that's times 2, right? So I'm going to put the distance on top, which is 37.5. And if I multiply that times 2, that's going to give me my answer. So 37.5 times 2 is 75. So I'm going to go 75 miles in 60 minutes, or 75 miles per hour. Okay? You good with that? Okay? Find the ratio that best helps you, that you can easily manipulate. Okay? So let's look at number 2. Okay, now this one I really want to talk about, and we're going to kind of stay together on this one because I feel like this visual is... Okay, so it says the battery readings on Victoria's tablet were as shown. A full battery is 10 units. What is the constant rate of the change in the tablet's battery readings? Okay, a full battery is 10. Constant rate of change. We talked about that the very first problem, and we said the constant rate of change is like a unit rate. Okay? So looking at these times here. Okay, they're spread over a couple of hours. Okay, when I think about battery time, I'm thinking, do I want to know the battery, how far the battery's going down per minute, per hour, per day? What do you think?
Hour.
I would say per hour probably. Why? Why per hour?
Because.
Pretty much every day you're going to need to charge it, right?
Yeah.
Okay, so per hour, but per minute seems a little hard to get to.
Every minute you have to be like, oh, it's going down this.
Yeah, like that would be hard to read, okay? So let's look. Do we see a conversion here that is an hour? Do you see a place where it's taken an hour's taking place, a time lapse?
9:15 to 10:15.
Perfect, okay? So 9:15 to 10:15. So at 9:15 the battery was 1, 2, 3, 4, 5, 6, 7. It was at 7 units, right? Or 70%, but we're going to go with units, okay? Because we're talking a full battery is 10 units. At 10:15 it was 1, 2, 3, 4 units. How much did that battery change in an hour?
3 units.
Negative 3 units per hour. Don't make it any harder than that. Does that make sense? This visual is asking you for the constant rate of change. In an hour, it changed 3 units. That's a constant rate. Okay, so we could pretty much say it drops 3 units per hour. That's how we would write that. Okay, so that's all it's asking. Don't stress out. People don't have a good thing with this particular problem. Okay, number 4. Petra bought 2.4 pounds of peanuts. Oops, wrong color. Okay, 2.4 pounds of peanuts for $15.40. How much did she pay per pound? Simple WKU right here. Okay, WKU. So my words would be set up as, we usually said money over whatever. So I'm going to say cost over pounds. So they told me it was $15.40 over 2.4. How much per pound for 1 pound? Okay, if you work this out, you could cross multiply it and get 2.4x equals 15.4. You would divide by 2.4. Okay, so we were struggling, some of y'all were struggling with the decimal part. Remember, it's outside, inside, up. Okay, so if you divide this out, you get about 6.416, and it starts repeating that 6 right there. But we're talking dollars and cents right here because we're buying something. So we're going to say it was $6.42 per pound. That's what we're going to go with. Okay. Okay, number 5. Okay, number 5. Jose was making a special meal for his family. The grocery store had 3 different brands of flour. Rank the brands from least expensive to most expensive by unit price. Okay, so this gives me my unit price. This first one, look. 1 pound is $3.50. I need to find out what 1 pound is on the rest of them, right? That's the only way to compare it, okay? So I'm going to compare this one and this one. So I've got to find the unit price. So let's do brand B. I'm going to say cost over pounds. So 4.15 divided by 1.5x over 1. That's brand B. And brand C is going to be the same thing. Cost over pound. And it's going to be 15 divided by 5, x over 1. Okay, on C, before I move on, I can clearly see that that scales down easily. So it's going to be divide by 5, divide by 5. So 1 pound is going to be $3. So our cost here is $3. We already found our cost here. It was $3.50, remember? Okay, so brand B is what we need to find. So how do we find brand B? What do we do? Cross multiply and then divide. So we have 1.5x equals 415. So divide both sides by 1.5. So 415 divided by 1.5. Outside, inside, up. It's going to go in here twice. 30, 45, 60, 75, 90, 105. So that's going to be 7. Okay. So, and then we would drop down, add another 0 and drop it down. We would go 6 and get 90, and it looks like it's going to repeat that. So I'm going to stop it there. So my cost is going to be about $276 for the brand B. Okay. So that being said, which one would be my least expensive? It would be brand B, then brand C, then brand A. Okay. So that's where we leave it. Okay. Any questions on those?
No.
Okay.